Okay, let's talk vector subtraction. So, again, the hard part, you might remember this stuff, me talking a little bit about this in grade 11, right? If you're talking, we're going to use a standard sort of plane in the wind scenario. So, the resultant vector is the plane vector plus the wind vector, right? The plane has a certain speed, sets the course, and it goes. And if there's no wind, that plane would travel in that direction and there'd be no problem. But there's always wind. The wind always blows it off course, right? And so the resultant is the plane's vector plus the wind's vector. And I'll give you a moment to jot this down. Okay, so what I'm saying here is that the resultant vector here, this dotted line, is the plane vector plus the wind vector, right? And the plus sign indicates that we are placing the vectors tip to tail. If you have to find the plane speed or the wind speed, well then you're going to have to rearrange. Because when the pilot sets his course, the first thing he has to ask is, which way is the wind going? Because if I want to go there, right, but the wind is blowing me that way, then I got to set my course over there. So the wind blows me back. Just like when you're golfing, right, Steve? Yeah. Right, if the wind is from right to left, I think we did one in grade 11. Yeah? Via components. If the wind is from right to left, you aim to the right of the green or to the left of the green? If the wind is from right to left, yeah, you want to aim to the right and let the wind blow it back, right? Same idea here. Okay? If you wanted, you could measure the wind speed, and if you knew something about the ball speed, you could make a calculation and figure it all out. Nobody really cares about that. This is what's important, right? So if you are asked to find the plane speed or the wind speed, well then it's going to become vector subtraction. If you're asked to find the plane speed or the wind speed, then it is a vector subtraction question. Think about that for a second. Does it make sense to you why it's subtraction? I'll read faces. I got a nod, I got a right? Because if I've got, let me show you here. If I've got R is equal to plane plus wind, right? And I want to solve for P, I got to take the W to the other side, and then it becomes negative P, right? R minus P is equal to, or R minus W is equal to P. And vice versa for the wind, right? If you're solving for the wind, that's resultant minus the plane speed. Okay? So this will mean vector subtraction. When you're trying to find the wind speed or the plane speed, or if it's a boat, the boat speed of the current, then you're dealing with vector subtraction. And then you got to deal with that whole, remember, flipping it around nonsense. Remember that, grade 11? Actually, I went back and showed you, you go, that's all it is? No big deal? Yeah, I know. Now that you're mature and wiser, know about logarithms and such. Okay, so do you think that vector subtraction with components is going to be easier? Quickly, how do we add vectors by components? Step one was find the x and y, add them together, and then take your x and y components and Pythagoras, make it on the triangle, carry on, right? What was the second step there? Find the x and y components, and the second one was to? So guess what the steps are for subtraction? Subtract them instead of add them. That is it, my friends. Lesson over. That's honestly how simple it really is. To subtract vectors by components, simply subtract them rather than add the components. That's it. That is it. Now, I like to see a nice big subtraction sign so that you're showing me on the test or the exam or what have you that, yeah, I know this is a subtraction question, so please show me that big subtraction question. And let's do this example one right here. And this will be a good refresher for vector addition, and for those of you that missed yesterday, well, then I guess you'll learn something. Okay, so step one is, next page, sorry. Step one, all I did there was just rewrite the the vectors, right? You don't need to do that. You got it right there. I just rewrote them so that it's right on the screen for us, okay? So step one is to break them into components. And I think I've got that, well, I've got the A right there. Okay, so how do you break them into components? So here's the initial vector, and again, yesterday, is it vital that you draw the picture?
Yeah, I like the
It's practically impossible to not do it, right?
pretty helpful.
Is it like a dot or an
Where?
arrow? The one on the left corner, yeah.
I think that's just, it's just a dot, but it just got drawn poorly, that's all.
That's just,
Okay, so 12 is, or A is 12 long, and it's at east 26 south. So label the AX, label the AY. The AX is 12 cos 26. I asked yesterday, is the X always going to be cos? No. Why is this one cos? Because cosine is adjacent, and this vector here is adjacent to the 26, right? So that's adjacent. The Y is opposite, so it's the sine. And for some silly reason, I don't have an actual numerical value there, which is quite odd. 12 times cos of 26. I get 10.8. It's to the right, so it's going to be positive.
How do you know where to put the degree? Like where you put the angle?
Like, are you saying, how come it's here and not down here?
Start
Because that's where you start.
The angle's where you do these because I'm right. 7.7.
Say it again, Ryan?
I'm getting 7.7.
12 cos 26?
Yeah.
Are you in radians or degrees?
I'm rating.
Don't be in radians.
So, I don't know. I'm just throwing off by the angle a bit.
Yeah?
This is look right. This look like this.
Okay, is that actually 26 degrees? No, that's probably more like about 55. But does it matter? It's just a sketch, right? It's just a sketch, so it really doesn't matter. I just do it like that so I could fit the 26 in there, that's all. I get 5.3 for the other one. Thank you. I was waiting to see if anyone would jump. Negative 5.3. Is that you, Maddie? Good. Why is it negative? Because it's
Going down.
down. Is that important?
Yes.
Oh, yes. Very important. Okay, solve for B now. Solve for B. Is that a better angle, Steve? Are you more comfortable with that one?
Yeah, that's a little better.
Yeah, you feeling better with that?
Mine looks like that.
Maybe I'll have to have an assignment. Write how you feel about the angle in this picture.
With 5 marks.
Yeah.
Feel okay, but whatever, I guess.
Did you come up with some numbers now? Or did you just wait for me? Guys, 8 times 14 cos 7.8.
7.76.
Okay. And the y is 8 times 14 sine 1.9, I guess. Anyone negative? Nope. Okay. Now, we were originally asked to subtract C is equal to A minus B, right? Generic, no situation, just here's 2 vectors, subtract them, right? Simplified. So I'm going to take this one, subtract that one, right? So what does that mean? It means that Cx is simply the x component of A minus the the x component of B, right? Just subtract instead of add. That is all. Now, just so you know, I like to do these. I'm not really sure why I did it like this. I like to rearrange them. When I'm doing them by hand, I like to do them like this. You don't like that? And do you know why I like to do this like this?
What? I'm a little bit thrown off.
I'm just rearranging them. Okay, now why do I like to do it like that?
Oh, sit
Yeah.
down. Whoa.
So I got x's on the left, Y is on the right, right? You could do that too. I show a nice big subtract sign there. You can do that too. Yeah. But basically what you're talking about here is that Cx is equal to, oopsie, 10.8 minus 7.8, which is a nice round 3. And here it's going to be minus 5.3 subtract 1.9. What's the next step there, Heather? I've got my components now. I've added them together, added or subtracted. What's the next step? Make the new triangle, right? And basically what we did was we broke them down into parts, did what we needed to do, and now we're going to put them back together. Sort of like Humpty Dumpty. We are all the king's horses and all the king's men. Why down?
Negative.
Because it's negative. Yeah, exactly. R squared is equal to 3 squared plus 7.2 squared. Do I have to put negative in there for the 7.2?
No.
Makes no difference, right?
Squared anyways.
You're going to square it, and it's just a directional indicator. $7.8?
Yeah.
And we don't even know what units here, right? They were just generic, made-up things because we wanted to make it simple. Do remember to include an angle.
How'd you get that?
Opposite, 7.2.
No, like the
This?
R, yeah, because
I
I
took-
squared them and I added them. I multiplied by accident.
Yeah, 3 squared plus 7.2 squared.
That's my fault.
So technically, would you have to use tan or no?
Oh, because you've got the hypotenuse?
Yeah.
Yeah, you could if you want. I just tend to use numbers that I've already, yeah. I guess I calculated these two, right? So, yeah, makes no difference. Oh, yeah, for sure.
Oh, yeah.
67.4, we'll just say 67 degrees. So that would be east, right, Steve? East first?
Yeah.
East, 67,
So.
south. And I like them in square brackets. What's the only thing different here from yesterday? This little subtraction sign right there. That's all that's different. See how easy vector subtraction can be?
So you would write like 7.8 east, 67 south?
Yeah. Yeah. All good?
Yeah.
Okay. There's a few questions there on page 116 you can try. I'm going to do what they call relative motion on Tuesday. So here's the plan. Friday, Tuesday, Wednesday, Thursday, Friday. Here's the plan. Tomorrow, unfortunately, I'm away. Yeah, I haven't been away that much, have I?
You were gone last
You were
Friday.
gone.
Yeah, that's true. Where was I gone last Friday?
You were skipping.
No, I was not.
You were at like a basketball game or something.
I thought I doctored.
Oh, yeah, right.
Oh, and before that, you were at a game of some kind. Yeah, you're gone a lot.
Yeah, I gotta go take my daughter in to see the doctor in Winnipeg. So, Tuesday. So we'll do that on Tuesday. We'll do relative motion, and that's not taking your family on a trip.
Oh, whiz.
Relative motion. I'm not sure that we need it, but we'll do that.
I won't be here.
Well, you're always away. Oh yeah, that's band, right?
No,
We
he's
talked-
not. He's not.
That's just you, right?
I'm going to the Jets game.
Oh,
Oh.
we boo.
Any other band members in here?
That's a good Jets game.
Ryan, you're in concert band, right?
Yeah.
Are you away next week?
Yeah.
Okay, so you and Hannah will have to
Like,
go like.
why don't we just do it on?
Why don't we do a double review
We
day?
could do
Nah,
it.
that seems like a lot.
Why don't we like
Well, then we're gonna start
have
doing-
have next Friday as a work period to catch up stuff, and so we can do our tests on Friday when we get back. And you guys are-
Catch up on what?
Like all the other shit. You have given us a lot of commitments. What are you whistling for?
Some locker room language.
What? What did I say?
S word.
Did I? Oh,
Yeah.
shit, sorry. I didn't catch it. Sorry. But like you gave us a lot of stuff to do. I thought that's what I said. I'm sorry about that. Actually,
If Hannah and Ryan want to write on Wednesday, they may.
we're also going Wednesday.
Oh yeah, you're going.
It's Wednesday, Thursday.
Oh, okay, I thought you were leaving Wednesday after school.
Nah.
Okay.
Then why don't we celebrate it on
It's like
Friday?
Wednesday right
Okay.
before lunch.
Well, I will do this, but then I reserve the right to start something new on Thursday.
No. The whole point was
Why don't
the other
you-
kids don't miss something new.
No, I am not going an entire week with only one new topic and a test. That's just not gonna
Well, I
work.
mean, it's only 4 days.
Well,
And you're gone on Friday. And
no, well tomorrow I am. Yeah, tomorrow. And I'm giving you a day to do some work to get caught up on. We are aiming for Thursday with the band people doing it at an alternative date. Those are some questions you can do. Let's just briefly talk about what's going to be on that test. Basically, there's 3 parts. There's graphing, which basically boils down to VT graphs
What's on the test?
to DT graphs, yes, right? And vice versa.
UT.
What do you mean by types of graphs?
Acceleration velocity.
Yeah, well, that's gonna say it on the side. It's gonna say. We haven't done much.
They'll probably say which one is it.
Yeah.
Okay, so what I'm talking about is you will have at least one where I'll give you a VT graph and you have to turn it into the DT graph. The opposite, DT graphs,
Yeah.
Your V's really look like U's.
yeah.
That's what it seems.
Stupid computer doesn't understand me. So basically one of each of those, and then there will be like that one I handed out yesterday where you have to identify the types of graphs. Like here's a DT graph, is it constant velocity, is it accelerated velocity, what kind is it? Or it might be,
Explaining what's happening.
yeah, identify what kind of motion we're talking about. Right? That's basically what we did in graphs, right? Okay. So that's sort of part A.
Fred and Barney.
Yeah, Fred and Barney.
Oh, cute.
So there's the,
Also multiple choice too, right?
yeah, not so much. There'll be kinematics problems. Now really, there's really only 2 kinds, right?
Christian Petrarchan, is that?
Well, there's,
Barney, and then there's just the classic.
yeah, there's Fred and Barney type.
What is that? Yeah, I've heard of it.
Oh, okay. Seven Barney. The Barney fault.
There we go, Barney. Right, so there's the collision kind, and I guess you could call them, I don't know, yeah, basic, classic,
Like this is the one where you're given everything but one. Yeah.
yeah. And I guess you would be asked to find VI, or VF, or D, or T,
Hey,
or A.
are you gonna give us all the formulas we need?
I'm going to give you 0 formulas.
Oh, we have to make a cheat sheet.
Oh, yeah.
Right? So, what the heck? So find VI, VF, or D, or T, or A, right? And then I guess the last part would be vector components. Now, what would I expect it to do? I might give you just give me what are the components, like a step one easy kind of thing, right?
So is this like gonna be pretty short then?
There's not going to be a whole lot to it, right? I mean, a Fred and Barney question will take you 10 minutes to do, though, right?
Yeah, I can't remember how to do that. Can you review one of those on Wednesday?
Yeah, probably, if you find one.
Oh.
Now, when I say a relative motion, I mean, like, basically a vector question that has a word problem in it, as opposed to, like, here's two vectors added together.
But we'll learn that.
Well, I mean, you really know how to do it. I'm just going to sort of remind you and give you some hints and stuff like that. I'll do that on Tuesday. So when you write it down, not a whole lot really, right? Not a whole lot. Okay, I will be quiet now. That is the end of today. I'm here to assist.